So we're on 8.2. A lot of this, I'm just going to tell you, probably need your graphing calculator out because you're going to want to try to remember how to come back up with this later. And if you don't do anything but fill out notes, it'll be more difficult for you to come up with in your brain when you're trying to do this by yourself. Test 2 is due Sunday night. So you want to make sure you get test 2 due Sunday night. 8.2 is not until the next week. So we're getting to the next lesson. So you want to go ahead and try to get that test 2 knocked out if you can. Any questions about that? If you need to ask me questions in lab, feel free to do that. So this first little section is actually pretty easy. It's just saying that if you have a polynomial, what you want to do is you want to look for the highest exponent that goes with an x, okay? Because that's your leading term. We talked about that in 8.1, that your leading term, you find all the x's and then you look for the x that has the highest exponent, and that's your leading term. Well, this is just saying whatever that exponent is degree n, and your polynomial will have at most that many roots or that many zeros. Same thing, x-intercepts. So it can't have any more than that many x-intercepts. Now, it might not have that many x-intercepts because we talked about last class something called multiplicity too. So sometimes they're listed more than once, and we're going to go back over that in this class too today. But at most, it will have n minus 1 turning points. And a turning point is a relative minimum or a maximum, basically where your graph goes from increasing to decreasing, or the other way around. It's going from decreasing to increasing. It's just where your graph makes a turn. Okay, so when we look at this, I'm looking at the terms that have an x in them, so x to the 5th and negative x squared. And my leading coefficient is going to be the one that has the highest power of x, that highest exponent power. So x to the 5th would win over x squared. That's my leading term. That means that this polynomial has a maximum of 5 real zeros and 5 x-intercepts. Those things are the same. And then to get the turning points, I want to do n minus 1. So I would do 5 minus 1. So it has a maximum of 4 turning points, or a maximum of 4 relative minimums or maximums, where it takes a turn from increasing to decreasing or from decreasing to increasing. Okay, when I look at this second one, I've got terms that have x's in them, negative x squared, x to the 4th, negative x to the 6th. Okay, which one's the highest power x? Yeah, my exponent with the highest, my x with the highest exponent as a power is going to be the power of 6. So that's my leading coefficient. That's my leading term. The other stuff doesn't matter here. So it will have 6, it could have 6 real zeros, no more than that. It could have 6 x-intercepts. And then I need to do n minus 1. It could have 5 turning points, but it doesn't have any more than that. But it could have up to 5 turning points, but maybe less in that problem. When you're trying to graph a polynomial function, it can get a little bit crazy because it's a little bit more difficult sometimes if you've got something with a higher power of exponents. So if you follow these rules, then this will help you. So the first thing that you can do is you can do the leading term test. I went ahead and drew that on the next page, but we talked about that in 8.1, and we'll talk about it again in just a minute, to find the n behaviors of what your graph is going to do. Okay, the next thing you can do is you can find the zeros of the function by solving f of x equals 0. Zeros are the same things as x-intercepts. So if your highest power of x is an x squared, what are you probably going to do to find your zeros? Most of you, I think, are going to do go to program and use your quad program to do that. Okay, if you've got an exponent that is 3 or greater, you're going to need to use your app and do that I think it's poly root something too. I might be writing that down wrong. We'll look at our calculator in just a minute. But you have to do the app if it's an x to the third or bigger, okay? But you can find your x-intercepts by doing those things. You're going to use the x-intercepts to divide the x-axis into intervals and choose a test point in each interval to determine the sign of all the function values in that interval. We're going to talk about that in just a minute. I think it'll help you better to look at that whenever we're going over that. Determine the multiplicity of the zeros. We want to do that because remember when we were talking about 8.1, that tells us if it crosses over or if it bounces or if it's tangent to the graph. If you do the multiplicity of zeros. Okay, you want to find f of 0. This gives the y-intercept of the function. We talked about how to do that in 8.1. We're going to go over that again. If necessary, you want to find additional function values to determine the general shape of the graph and then draw the graph. Sometimes those minimum and maximum values can be important to find so you know exactly how far to go down. As a partial check, you can use these facts that were listed above that you are not supposed to have any more than n x-intercepts and no more than n minus 1 turning points. And you can also look at the graph on the graphing calculator. Okay, so that's a lot of stuff to kind of take into account. So we talked about this on 8.1. But you can pick out what a graph, if you have a bunch of graphs and you've got equations, you can pick out which graph it is pretty quickly if you just can do the leading term test and the y-intercept, okay? So remember that the leading term test, if the function is even, so if it is even, that means the highest power exponent is even. Okay, and if the leading term in the front, the leading coefficient is positive, remember if it's even, both of your endpoints are going to be pointing up. If the leading term is negative and it's even, both of your endpoints are going to be pointing down. Okay, if it is odd, your endpoints are going to be pointing different directions, but if it's greater than 0, your function is kind of going to be increasing, like starting small, getting bigger. But if your leading term is less than 0 or negative, it's going to be starting big and getting smaller. Okay. We talked about that on Monday. Another thing that we did is we talked about how to find the y-intercept really easily. So basically we said, okay, if you want the y-intercept, then x is equal to 0 when you find the y-intercept. So every single one of these will be 0 something all the way down because the y-intercept, x is 0. We can go ahead and just jot that down. That's going to happen. Okay. So when you plug 0 into an equation, if for x, we're plugging in 0 in for x, if it has an x, if the term has an x in it, it's just going to turn into 0. So the only thing you're going to be left with in any of these is whatever the constant value is. And so the point would be at 0, 5. What about this one? If I plug in a 0 for x here, this is going to go away. This is going to go away, right? What am I going to be left with? -3. Okay, so if you can just pick out what the y-intercept is, and you can reason out what some of these graphs are pretty quickly. What's the y-intercept on this one? -4, because every other term that has an x in it is going to turn into 0. So all you're left with is this end point or the constant term. It might not always be at the end, but it's always the one that doesn't have an x. So -2/5 x is going to go to 0. We're left with 4. This one doesn't have a constant number, so what's it going to be? 0. This one's the same way. It's going to be 0. We could stick a +0 out here or a -0. It doesn't matter, right? But it's just going to be 0 if there's no term there. What's this one? The x to the 5th is going to turn into a 0. -x to the 3rd is going to turn into a 0. So we just have 2. This is going to turn into 0. This is going to turn into 0. We're left with -1. So this one would be 6 because x squared is going to turn into 0. 7x is going to turn into 0 when you plug it in 0. And this right here, there's just, all we have is a constant. That would also be 0, 3.5 if you do 7 divided by 2. And this is just a horizontal line that goes through y equals 3.5. This one doesn't have a leading term. I'm going to put not applicable. Which graph is this one that matches this? F, right up here at the top, right? It goes right through where y is equal to 3.5. I'm going to mark that one out just so we can not worry about it and come down here and put that this one is F. Okay, we already know that. Leading term test. When you're doing the leading term test, the first thing you do is you find the highest power exponent, and I'm going to circle this term. So this is my leading term because x to the 4 would be the highest power exponent I have on any x. Is 4 even or odd? Even. So I know that either both of my arrows are going to be facing up or it's going to be facing down because it's even. Then I'm going to look at my coefficient that goes with that. Since there's no number here, this would be a -1. So it is a negative number. So I wouldn't go with the greater than 0. I'm going to go with the negative over here. So this function should do something, but both of the endpoints should be facing down. Okay, so I'm going to kind of scroll through my graphs to look for endpoints that are facing down. It looks like H has both of them facing down. D has both of them facing down. Y'all see any more? So now we've got to decide based on our y-intercept. Is it H or D? The y-intercept is supposed to be 0, -3. So wait, did I go all the way back up? No, yeah, 0, -3. So this one looks like it's 0, 5 is the y-intercept. This one does look like it's 0, -3. D? That y-intercept is at 0, -3. Y'all okay with that? Did I skip one? Oh, sorry. I was doing the second one. Thank you for catching that. 0, 5, right, is the y-intercept facing down. That's my fault. So this one does have a y-intercept at 0, 5. So H on that one. Be okay? It's facing down. Y-intercept is at 0, 5. X squared would be my highest power of exponent. That is also even, a 2. I've got a -3 in the front, which means that facing down. So this one's supposed to be, we already kind of worked this one, 0, -3 is the y-intercept. So this one would be something that is, both of our endpoints are facing down, and we've got a y-intercept at 0, -3. So D, everybody okay with that? Okay. The highest power exponent on an x here is x to the 4th. That is even because it's a 4. And it is a positive because the number would just be 1. So if you come up here and you look at even and positive, it's supposed to be something that both of the ends are facing up. So G would be a possibility because both of the ends are facing up. C would be a possibility because both the ends are facing up. J would be a possibility because both of the ends are facing up. So we need the one that has a y-intercept at 0, 4. So G, it looks like it could possibly be 0, 4, but it's not on the graph. C is definitely not that one. Those are both facing up, but that looks like 0, 0. Y'all agree with that? And then the other one that's facing up looks like it's 0, -4. which is what we're supposed to have, right? 0, -4. I think I said 0, 4 before. Sorry. 0, -4. So it needs to be J. Mark that one out. We're done with that one. This one's highest power of exponent is a 1. So it is odd, which means that the endpoints are going to be facing different directions, and it is a negative, which means it's going to kind of go down. It's going to start big and get smaller. It's going to make some kind of shape like that. So this one starts small and gets bigger. So no, this one starts big and gets smaller. This one starts big and gets smaller. This one starts small and gets bigger. So it's either E or B. Those are the only ones that kind of go down or decreasing. So we need one that has a y-intercept of 0, 4. That's it, isn't it? 0, 4, B. Just marking them out, so because this one has a y-intercept of 0, -1. Y'all catching on? Okay, this one has the highest power is an x to the 3rd, so it is odd. Okay, so that means that it is going to be, the ends are going to be pointing different directions. It also is positive, so it means it's going to start out small and get bigger. So that would be like A. Different direction, starts out small and gets bigger. A has a y-intercept of 0, 0. Go ahead and take care of that. I starts out small and gets bigger. It looks like it has a y-intercept of 0, 2. So is either of those going to be it? Which one is it? We've got to have an intercept of 0, 0. Yeah, A. So starts out small, gets bigger, has a y-intercept of 0, 0. Are you okay with that? We've got a y-intercept, or we've got an even exponent here is the highest one, and it's positive. So that's going to be, means it's, the even part means that both of the interval, or both of the ends are going to be pointing the same direction. And because it's positive, they're both going to be going up. And my y-intercept is 0. So which one do you guys say? Both of the endpoints are going up, and I have a y-intercept of 0, 0. Did y'all tell me? And I didn't hear you. See? Yeah. Facing up, 0, 0 is where it crosses the y-axis. Absolutely. Okay. This one is odd and positive. So if it's odd, they're going to be going in different directions. The endpoints are in different directions, but it is going up. It's increasing from least to greatest, and the y-intercept is 0, 2. Which one? I. Okay, this one is odd, so the endpoints are going to be different directions, but it's negative. So instead of going up, it's going to be going down. My endpoint, or my y-intercept, is 0, -1. E. Okay, this one has an even. So that means that both of the endpoints are going to be going the same direction, either both up or both down. And it's positive because this is just a 1. So they're both going to be going up. We only have one left, so hopefully that fits our description. It needed to have a y-intercept of 0, 6. So if you could, this is 4. So if you can kind of imagine a 5 and a 6 up here. I mean, yeah, it would kind of touch at 6. The E's kind of, does that make sense? So yeah, G. So you shouldn't have to go to y equals and graph things every single time if all you're having to do is recognize what kind of graph it is. You should be able to kind of eyeball it and go, it should look like this or similar to this. Based on those things, you should have some idea of how to get the graph. Okay, so If it asks you to graph, this goes back to the page before and it had all this do 1, 2, 3, 4, 5, 6, 7, 8. Okay. If it asks you to graph, and we're just getting a really rough graph here. We're not trying to make it look perfect, but if we wanted just a basic picture of what our graph needs to do, if you're given this, okay, you should know that if you FOIL this out, when you do first, outer, inner, and last here, you would get x squared minus 3x plus 2x minus 6. So x squared minus 1x minus 6. Okay, so A is 1, B is -1, C is -6. I'm just pointing out some things that we should know about this graph, okay? I'm going to come over here and just draw me an XY axis. Does everybody agree that you at least know that part about this graph?
Yes.
Okay. What's the highest power of an exponent you see? The 2. So it's quadratic. It's a second degree polynomial. Talked about that in 8.1. You could go to your quad program on your calculator and type in A is 1, B is -1, C is -6 to find the x-intercepts, right? Because that would at least give you 2 points. So I'm going to draw me a little table over here, but they've already got it in factored form right here. So if that's the case, then I could just go and solve for 0 and say, well, I've got an x-intercept at x equals 3. I mean, your quad program will tell you the same thing, but those would be my 2 x-intercepts. Is everybody okay with that? This is x and this is y. I know that I have a point at -2, 0 and at 3, 0. I kind of left some spaces in between there so I could get some other points. -2, 0 and 3, 0. This is from 8.1. What multiplicity, we kind of broke these up in 8.1 and we said if we have the point 8, or if it says x minus 3, that's raised to the first power, so that has a multiplicity of 1. What did that mean? It had to do with either crossing the x-axis or bouncing off of it and being tangent to it. So if it had a multiplicity of 1, it's odd, it crossed over the x-axis. Y'all remember that? If it had a multiplicity that was even, it was a bounce, or we call it tangent. But both of these have multiplicities at 1, which means that they're going to cross over the x-axis at these 2 points, which we kind of already know. What about the y-intercept here? Is it easy to pick out? If x is 0, both of these, x is 0, -6. So 0 would kind of be right here, 0, -6. So I know that point. I have to go down a little bit, 5, 6, 0, -6. Okay. So is this graph going to be facing up or facing down? I'm going to look at my leading term, right? The leading term is positive, so both of my endpoints are supposed to be facing up. So I already know, and we're not going to worry about finding the minimum or maximum here. We're just finding the rough graph of this. My graph should kind of look something like that. It's supposed to cross over at those 2 points. It's supposed to be facing up. We've got enough points to kind of get a rough graph. We're not trying to make it perfect from this. Okay. Okay. We have the graph over here on this one. So I know that my leading term is -2 x to the 4th. It's even, so both of the endpoints should be facing the same way, and they are. They're both facing down. It's negative, so they should be facing down, not up, right? We already know that from looking at our graph. Okay. it says, but this one says find the multiplicity of the zeros. So that's this part. So if I go to my graphing calculator, can I find my zeros on this since it's at x to the fourth? You've got to use the polynomial root finder. So I'm going to go there just to remind you how to do that. So when you go to your polynomial root finder, get out of here, you're going to go to your apps button. In a minute, I'm going to ask you to tell me what you get on this. So, but we're working this one together. So I'm going to go down, I hit apps. I'm going to go down to that. There it is at Poly Simulator 2. I'll hit enter, Poly Root Finder, enter. And this one, the highest power of exponent is a 4, isn't it? Yeah, x to the fourth. So that's why I want 4 to be highlighted. If it was next to the third, I would move it over here. I want the 4 to be done, so I'd hit enter. So to get to the next thing, you're going to hit the graph button because graph is right underneath next. A to the 4 or A sub 4 means what is plugged in or what is the coefficient in front of x to the fourth, and it's -2. So you type that in, you hit enter. A sub 3 means what coefficient's in front of x to the third, and ours is a 3. So we'll put 3. A sub 2 is what coefficient's in front of x squared. I don't have an x squared, so I put 0. A sub 1 would be x. I don't have that. A sub 0 would be your constant term, and we don't have that either. So I have typed in a -2 and a 3. I would like it to solve it for me, so I'm going to hit graph because graph button is right underneath the solve, and it tells me 0, 0, 0, 1.5. Okay, is everybody good with that? So when we go here, remember that they told us that we had x sub 1, x sub 2, x sub 3, x sub 4, and they said the answers were 0, 0, 0, and 1.5. It's 3 over 2 is 1.5, right? 3 divided by 2 is 1.5, and our other point is 0. So that our graph was good. It looks good as far as our x-intercepts go. But the multiplicity comes from factoring the problem and figuring out what the exponent is here. So let's talk about this and see if we can, because some of you are going to probably struggle with this. So what I'm trying to do is factor -2x to the fourth plus 3x to the third, so I can figure out the multiplicity. What's the highest power exponent and x? I guess x to what power is the highest between, or the lowest between these two? And we want, so since x to the third is the lowest power exponent, I can at least pull out an x to the third because both of these terms have an x to the third in them. But that's all I can pull out. -2 and 3 doesn't have anything in common. So if I take an x to the third out of -2x to the fourth, I am left with -2x. If I take an x to the third out of 3x to the third, I'm left with +3. Okay. So if I were to multiply this stuff back out, x to the third times -2x, that would give me back -2x to the fourth. X to the third times 3x would give me back +3x to the third. So that's factored. That's what I need to kind of figure out my multiplicity. So really, I've got two things with an x in them. I've got x to the third, and I've got -2x plus 3. Well, this is the easiest one to kind of figure out because it's just raised to the first power. So when I solve -2x plus 3 equals 0, I would subtract 3. This is the last, we're doing example 3 and 4. I know this is kind of complicated, so hang in there with me. And I would divide by -2. So we're not going any further than 8.2 today. So I would get 3/2, which we already knew. That's what this point is right here, right? This one, I could change and say x minus 0 to the 3rd power. So I would solve this for, set it equal to 0, add 0. So x is equal to 0, which is this point right here. The multiplicity part comes from what the exponent is. So this exponent is a 1, which means it's odd, which means it's going to cross over. If it was even, it would just bounce. At 3/2, it does cross over the x-axis. This 3 is odd, which means that it's going to cross over. It's not going to bounce, and it does. It crosses over the x-axis there. And so so here's what I want to ask you. This 0 has a multiplicity of 3. This 3/2 has a multiplicity of 1. Do I have to factor it to come up with those answers? Look at what the calculator gave you. No. Because if you can use the app on the calculator, then this should tell you that 0 happened 1, 2, 3 times. So 0 had a multiplicity of 3. So we can factor it to find that out, but we also can look at what the answers are. 1.5 only happened once, so it had a multiplicity of 1. Okay, so that answers this question. Find the multiplicities of the zeros. Okay, but if we were doing it by hand, that's how you do that. You factor the problem out. Okay, they're telling me to graph this polynomial function. What's the best place to start? Find the zeros, right? Find the zeros. So if you're following online, go ahead and go to your polyroot finder and find the zeros. This time you're going to have to change. It's not going to be x to the, we put the 4 in there. You need to put a 3, right? We want to put x to the 3rd. Okay, and so I'm going to go ahead and make me a chart over here. Following online, make sure you type what you came up with for your zeros in the chat. Takes just a little bit of time to type that in, I know. Okay, has anybody got any of the zeros yet? What do y'all got? Okay, and -1/2 and -0.5, same thing. It doesn't matter which one you put, right? Are you guys okay with that? So right now, I know on my graph, I can say I've got a point at negative. I'm going to kind of put these in order and skip down a little bit. -2 zeros a point, -1/2 zeros a point. I'm skipping some space in between. -1/2 0 would be right here. I'm skipping some space in between here because I need to pick some other points so I can see what's happening with the graph. Anybody confused about how to find the zeros? Another point that's really easy for me to find is the y-intercept, because that's this, right? The y-intercept is when x equals 0, and 0 would fall in between -1/2 and 2. 0, -4 would be the y-intercept. So I can go ahead and plot that point, 0, -4. That should happen. When I look at the leading term, it's an x to the 3rd, which means that the endpoints are going to be pointing opposite directions, but it's positive, so it should be increasing. It should do something like this, right? So since it's positive, I know that whatever's happening with my endpoints, the endpoints are going to end up doing something like that, right? Going down to begin with and up. I'm going to have to find some other points on my table to be able to make this make any sense. So what can I do? go to y equals and type in 2x to the third plus x squared minus 8x minus 4. I know you guys know how to do that, so I'm not asking you to do that right now. But when I did that, I found some other points. And the other points that I want to look at by doing second table, the other points I want to look at, I tried to pick things on both sides of my intercepts. So I went -3, gave me -25. I already had my x-intercept here. I picked -1, 3. I'm just trying to find, this one was already on the other side. So I also found a point at 1, -9. And so you're just trying to kind of fill in the blanks to make sure that you've got a complete graph. So -3, -25 is not going to fit on here. -1, +3 does fit on here. 1, -9, way down here. 2, 0, and then 335 is not going to fit on here. Once again, I'm not saying make the perfect graph here. I'm just saying try to get it to be close to what you following these rules. I didn't make a lot of effort to find the perfect relative minimum or maximum. That would be the last thing I would want to do if I was going to make it exactly perfect. But we're just trying to get a rough picture of what the graph looks like. Okay, so that's kind of what where we're at. So this one says, just give an example of the graph of this polynomial function. So what might it look like? Well, I know that my leading coefficient is x to the 4th. Or my leading term is x to the 4th. The leading coefficient would be 1. So this is even, which means both of the points are facing the same direction. The number in the front is positive, so whatever this does in the middle, we don't know, but it's going to be facing up. Okay, we know that. We know also that this thing has a y-intercept, so when x is 0, y is -16. And I'm not, like I said, I'm not making a perfect graph here, so I know there's a point down here at 0, -16. I know that. I'm going to have to find some x-intercepts to complete this. So when I went to the polynomial root finder, I got some, so I typed in my x to the 4th and did all that stuff. And I got some crazy answers. Here's what I got. And this is probably going to happen to you sometimes too. So I want you to be able to see this. I got 4. I got something like 2.00005, 1.99992, and -1. Okay, yours might not have done that, but sometimes the calculator does crazy things like this. These two are very close to what number? 2. Okay, and in 8.1, we learned that if I want to know if it really is 2 for both of these to be 2, what I need to do is go and plug in 2 into my equation. Wherever I see an x, if I plug in 2, if it really is a 0, if it really is a root, when I plug in 2, what should be the answer? 0. So if we plug in 2, the answer should be 0, and guess what? It is. Okay, so if I go and plug in 2, so that verified for me that both of these were actually 2. It just didn't round correctly. So I have a x-intercept at the point 4, 0. And at that point, it only happens one time, right? So it has a multiplicity of 1. Just has a multiplicity of 1, what happens there? It crosses over the x-axis. Okay, I have another y-intercept at the point 2, 0. So at the point 2, 0, sorry about that. At the 0.20, this one has a multiplicity of 2 because it happened twice. So at 2, it's not going to cross over. What's going to happen? It's going to bounce off. It's tangent. It's going to hit it and then bounce off. You'll see what happens with that in a minute. -1. Back up. -1. It only happened once, so it had a multiplicity of 1. So it's going to cross over there at that point. It should bounce right here, cross over the x-axis at the other 2 points. The last thing that I did was I went and I got some points from I went to y equals. I typed this in and I got some points kind of around these values. So I said, well, what's -2? -2 gave me 96, which makes sense because this thing is supposed to be facing up. So -2, 96 would be like way up here. Y'all agree with me? That's going to be facing up. I didn't find a point between those two. I just went down here. And then I looked at 1 was supposed to be -6. Once again, we're not doing this perfectly. We're just kind of getting an estimate. 1 is -6. Remember that it's supposed to just bounce off of this. So if it bounces off, it's got to go somewhere. So I had to find a point between 2 and 4, and I looked at 3, and 3 is -4. It'll bounce off, come back up. It has to come back up because that's what my end behavior is supposed to do. This is a rough graph. It's not perfect. If it was perfect, we would actually find the minimums and maximum values, and like these 2 points, we would find the exact value of how low or how high it gets. But that's a rough picture of what the graph is supposed to look like, okay? So from 8.1 and 8.2, you should be able to do that.